All right, there we go. So number 24. Here we go, guys. Okay, so it says find the sum of this. On the exam, we won't know for sure whether it's arithmetic or geometric, so you'll have to figure that out. And when you look at this, you notice that common ratio is -1/2. Every time you're multiplying by -1/2 to go from first to second term, second to third, third to fourth, and so on and so on. So the R is -1/2. So we have a geometric sequence, which means since we want the sum, we're going to use Sn equals A1, 1 minus R to the n over 1 minus R. Another way to say that, let's plug in what we know. A1 is 1. R is -1/2. I'm going to simplify the top and bottom a little bit. Let me stop here first and see if there are any questions on how we got this. Alright. So we need to find this n. And in order to find n, we're going to need to use the other formula, which is a sub n to find the nth term. So David, here you go. That's scratched out. 30 minutes with the calculator. You can show all the work, please. You plug in. You can go take it wherever. So just come back. It's 11:54, so 12:25. Okay. You can grab as much paper as you need. So we need to find n. So we need to find how many terms are we adding up. So -1 over 512. So -1 over 512. We need to see which term number is that. Is it term 8, term 20, term 30, term 12? Who knows? Let's find out. And that is equal to A1 times R to the n minus 1. We know A1, we know R. Let's plug those in. How am I going to get this n? Eddie? Yes, logs are coming back. So now, slight problem here, guys. Slight problem. We can't take log of a negative number, so you need to get rid of these negatives here when you're doing this log, please. Please get rid of these negatives. Remember, you can't have log of a negative number, as you all know. Right. Yeah. Yeah. And specifically for this geometric type problems. So you have 1 over 512. Natural log of both sides. Alright. This exponent comes downstairs in front. These are both numbers, so we can divide both sides by ln of 1/2. Remember, we're trying to solve for n. .5 is the same as 1/2. And we can do this on the calculator. ln of 1 over 512. So you will need your calculators here for many of these problems, so please get those out. Those have it. So we need ln of 1 over 512 divided by ln of 0.5. I'm getting 9. Please verify you're getting that. That equals n minus 1, so n equals 10. So now this 10 needs to come back in here, so we can find the sum. So S10 equals S10 equals 1 minus negative 1/2 to the 10th power, all divided by 3/2. Because all we did is we took a 10 and put it here for n. So let's take a look at what this equals. Well, this is just 1 minus negative 1 to the 10th over 2 to the 10th, all divided by 3/2, which is 1.5. Please understand that if you have a fraction, you can split it and do the numerator to that power divided by the denominator to that power. So this is 1 minus negative 1 to the 10th is just 1, and 2 to the 10th is, well, some huge number we'll get on the calculator, all divided by 1.5. So let's let the calculator do the work now. And please verify you're getting this. Let me stop here and take questions before we go to the next round. Because you didn't divide by 1.5. Other questions on this? Lee? Yeah, if you could put this in a fraction, go for it. Mariah.
Okay, so you have to find which number in the, which term the negative 1/512 was, right?
That's right.
Use that as a formula.
That's right. That's right. Okay. What happened? You're not getting that answer. Okay, let me see. So on number 28, so it's do the 1 minus 1 over 2. So this is the problem. We just put a parentheses here. Because you don't want to divide by the 1.5 first. That needs to happen at the end. And now divide by 1.5. Okay, number 28. Now, number 28 is similar to problems we've done with arithmetic sequences, except now we're going to have geometric. So it tells me A3 and A6. So A3, 63 over 4. A6, right here. And they've told me this is geometric. They have to tell you whether it's geometric on a problem like this. So we have 3 jumps. And each jump we are multiplying by r. So if we have r times r, that's the same as r cubed. This is the difference between this geometric and arithmetic. With arithmetic, we did like 3 times the common difference, or 8 times the common difference. Now we're doing the ratio cubed. That's equal to, with arithmetic, it was this minus this. Now it is this divided by this. Why? Because with arithmetic, we were adding common difference, the opposite of adding, subtracting. Now we are multiplying the common ratio. The opposite of multiplying is dividing. So this divided by this. So we need to keep change flip over here. Now, we can reduce this, because this could have been a non-calculator problem, so we can reduce this, bless you, before multiplying. We can divide both the 4 and the 32 by 4. This becomes 1, this becomes 8. We can do 63 divided by 3, that's 21. 1701 divided by 3, if you don't know that, you can kind of do it over here. Remember, this could have been a non-calculator one, 567. You can again divide by 3. 567 divided by 3, some of you may know that. If you don't, you can do the division over here. What you'll get is 89. Both of these divide by 7. 7 divided by 7 is 1. 7 goes into this, either you know it or you can do it on your own. It's 27. So what do we have? We have 27 times 1, which is 27, and we have 8 times 1, which is 8. So we have r cubed. We have r cubed equals 27 over 8. We got to solve for r. Cube root here. Cube root of r cubed is r. Cube root of 27 over 8 is cube root of 27 divided by cube root of 8. Cube root of 27 is 3, and cube root of 8 is 2. So again, please see how we split this up into this. That's totally allowed. So we have r equals 3/2. And remember, our goal is to find a5. Well, we know this is geometric, which means a5 will equal a1 times r to the n minus 1. So a5 equals a1, we don't know what that is yet, times r, we do know that's 3/2, to the n minus 1. So we need to find a1, and then we'll be set. So let's find a1. Eddie. You are totally allowed to do that. But on the exam, it won't be so nice. Right, on the exam, it'll be like, find like 820 or something. But here you could do that for sure. But like we want to like build the habits to make sure we can do this. So when the problem is not like this, then it's doable. Does that make sense?